So the minus sign indicates that it's a restoring force. It's directed to restore the mass to its equilibrium position. Now the force is not constant, so the acceleration is not constant either. Newton's second law says sigma F is equal to ma, therefore A is equal to sigma F over m. If the force is the spring force, it would be equal to kx negative divided by m. Therefore, if the displacement is positive, the acceleration is negative, and if the displacement is negative, the acceleration is positive. They will always be in the opposite direction. The maximum force exerted on a mass is when the spring is most stretched or most compressed. So x would be equal to either the positive amplitude or the negative amplitude. So the force would be equal to k times the amplitude. The minimum force exerted on the mass is when the spring is not stretched at all, when x equals 0. So when it's at the equilibrium point, the force is equal to 0. When the spring is all the way compressed, the displacement is in the negative amplitude, the force on the spring is in the positive direction, the acceleration is in the positive direction, and the velocity is 0 because it's stopped. When the spring is at equilibrium and heading in the positive direction, the displacement is 0, the force on the spring is 0, the acceleration is 0, and the velocity is positive and at a maximum. When the spring is all the way stretched, the displacement is at the positive amplitude, the force of the spring is in the negative direction, the acceleration is in the negative direction, and the velocity is 0 because it's stopped again. When the spring is at equilibrium and heading in the negative direction, the displacement is 0, the force on the spring is 0, so the acceleration is 0, and the velocity is negative and at a maximum. Gravity does not affect the mass spring system. If the spring is hung vertically, the only change is in the equilibrium position. It is just shifted down. Otherwise, everything else is the same.